edition of EMSNOW Up Close. I am Eric Miskell with EMS Now, and it's my pleasure today to have Ken Law with PowerArena joining us from Hong Kong to tell us about his company, which I think you'll find will be fascinating. I love the technology and what Ken and his group are doing there. Ken is the co-founder and CEO of PowerArena. And Ken, thank you for taking time and joining us today, sir.
Thank you.
Yeah. Listen, why don't we begin by allowing you to introduce yourself and your company for the benefit of our audience?
Oh yeah, I used to work in Google in the Bay Area, and when Google was still relatively small. And then I came back to Hong Kong about 10 years ago, started my first company on mobile app development. Well, that was the coolest technology of the time. And 5 years ago, deep learning started to come out. And that was, another coolest technology I've seen. And then that's why I'm starting another company on manufacturing, but that is also based on the new technology.
Okay. And so let's tell them what that is. What you do is, I'm going to say how I understand it, and you're going to tell me how I'm wrong. Okay. So I think that, as I understand it, you take AI applied to labor-intensive operations in manufacturing environments. And so the data that you analyze and help improve, and then is human behavior in labor-intensive parts of electronics manufacturing and other manufacturing, right?
Yeah. So many of my family and friends are in manufacturing. Many people in Hong Kong, they still have a family business in manufacturing. And I'm kind of like the best technology guy that they know. And so they used to ask me a lot of questions related to ERP, MES, and things like that. And I think manufacturing is one of the few industry that is so big and making real impact to the economy. But at the same time, in terms of the IT, it is relatively low tech. Like the best technology that they have is the ERP solution. So I think there must be a lot that we can do over there. And then the Industry 4.0 came out. And my friends look at those technologies, kind of like space technology to them. That they don't find relevancy to what that they are doing every day. And that's how we started to think, hey, is there something that we can do over there? And as you know, in Asia, it is still very labor intensive, and it could be really expensive as well. Like 40 people working in China 24/7 can cost up to $1 million US per year. But how do you manage that operation, right? That is so expensive. It is still by industrial engineers doing motion study, using paper, pencil, and stopwatch. That's something that we can do over there. So basically, the deep learning in terms of the computer vision technologies is kind of like replacing the human eyes. And so we are doing. So traditionally, to understand what's going on in the manufacturing line, the IE, the industrial engineers will measure the cycle time, looking at different stuff, find out the root cause of the problem, and then improve the line. And so we are basically using technology, again, computer vision, to do that instead of doing that manually.
And what you do is you put the cameras in the facility on whatever area that has been identified as being a problem or a bottleneck, or however you describe that. And then you video or image that, and it goes to and then based on that, you get the output on how to improve whatever might be the problem.
Yeah, the way that we do it is we have a strong focus on the assembly line. And so usually, it could be, 20 people line, but usually it could be, 40 and 60 people in the line. And we put a camera on top of the line. And so we don't see the face, and we don't do any facial recognition. So, and that's not what our clients care about. We are looking for systematic problems in the line. And so we can understand the motion of the worker. So, they pick things up, they put things down, where they put it, and the time that it takes. And so we are gathering a lot of information from each workstation, from each operators. And so there are, obvious application for this, like looking at the cycle time and the line balancing of the line, because people are working one by one in a one-piece flow line. So if one person is slow, it's kind of like, or if one operation is slow, it's kind of like slow down everyone. And so we identify the bottleneck, and the industrial engineers can also categorize the problem and then find out and put down the reason. So a lot of time, what we have learned is not that people are lazy, that they're, and which is very easy to say that, today's manufacturing, the production is not good because someone is lazy or things like that. Turns out that that's not the case. Sometimes the tools that they're using is breaking down. Sometimes the line is not balanced at all, or there are new people coming in that they are not as fast as the people before, and so they need a bit more training. And so we find out all those problems, and then the industrial engineers can then think about the solution to those problems, and then improve efficiency of the line.
So 2 points on that then. So, because in one of the videos I saw online for a demonstration of your product, it showed as an example that there were some maintenance workers who came so there was a log jam on the line, but it wasn't because of the worker. It was because when you looked at the video, you saw there were some maintenance guys there who were crowding the area and causing a disruption, right? So it could be environmental, or I was thinking it could also be just the way they structure a particular job might be problematic, right? If somebody has to move around a lot, that could cause problems as well. So.
Yes, exactly.
Okay. And so now, who does so the cameras are there. I'm assuming that the way this works is you work with a company, you look at their baseline data and figure out where some problems areas are. You put the cameras in, you do the analysis, but who identifies, is it then the industrial engineer of yours or of of your client companies have to then look at it and assess the video to see what is actually happening?
Yes, the AI is going to find out all the problems, but how to categorize those problems. And now that we know that the root cause could be the maintenance guy, for example, how to resolve those problems is still based on the human expertise. And the way that we work is, after they use PowerArena and they find out a lot of data coming out, and usually they are a bit overwhelmed by the data. But then we have data scientists working with our clients, industrial engineers, to understand the data. And now they can use data to answer the questions. So for example, how is my daytime worker, performance of my daytime worker comparing to my nighttime workers? And so will people do fatigue on this operation for too long? Because now this is, pretty repetitive. And if they get fatigue, should I be, giving them more break, and so that they can get back to their performance. So they can use data to answer a lot of these questions that they could not answer before.
No, and that's actually very good insight. And you're right. I know that within the time and motion studies, they always account for PDF, right? PDF, right? Personal delay and fatigue, right? As you're talking about it, right? We used to call it piddle, diddle, and fiddle, but that wasn't the right term. It was personal delay. But that's just people, like you're saying, doing a repetitive motion over a period of time. You can anticipate some kind of degradation of the quality of the work. So that's a good insight to have. So Now, tell me then, so what are the most common applications that you're finding as you're working with companies for your applications in electronics manufacturing?
Yeah, so right now we are mainly focused on the big, top 10 or top 20 EMS companies. And so they really have long manufacturing line, they're working with, mobile phones and other products. So our main application is in the light balancing application that I mentioned earlier.
Yes.
But now we are starting to help smaller companies. And so they don't have such a long line, but their problem is more like, the skillfulness of their workers. And they have high mix low volume, right? Meaning, the product is changing, every 3, every 4 hours. And sometimes it happens that, the operator is not following the SOP, the standard operation procedures, or they forget some of the steps. And so we have new application that, if they forget something, we send them a gentle reminder so that, hopefully they can follow the SOP. It's kind of like when you're using Microsoft Word, that when you type the wrong thing, they have a gentle red underline that reminds you, helps you to, write a better article, right? So so it's kind of like the same idea.
So you do that real time?
Yeah, in real time.
And how is that? How do you prompt them then? Is that through, how is the worker prompted?
Yeah, so this is still experimental. This is something that is new, but we are using lights. So they put the lights over there. And so usually it's not lighting up, but if they miss certain things, so we just light up and give them a reminder.
Okay. That's interesting, because I've seen that with augmented reality where they show the work instructions lit up, right? They can demonstrate. So that's what I'm thinking of as you're doing this. So it's interesting that you say it with lights, that it kind of prompts them. So
yeah, the AR glasses, again, kind of like a space technology to our.
Yeah.
So they are thinking of something more down to earth, I would say.
Yeah, no, I appreciate that. Now tell me though, because what you refer to as BYOAI is an interesting concept there. Tell me about that and how that benefits your customers.
Yeah, so so when we first started, we have some we train our AI to understand certain motion, right? But turns out that those are not enough. In the real manufacturing environment, there are all kinds of strange things happening. There are always things that we haven't seen before. And so in the old days, they say, oh, that's how I put this item into my machine, a strange kind of insert, and we don't understand it. And hey, PowerArena, can you help me to recognize this motion or this step? So there's a lot of back and forth, right? So we take the data, we do the training and we do the communication, and then we deploy the solution. It's taking too long, and there's no such luxury, I would say, in the manufacturing environment. Everything needs to happen quickly, and so we kind of like now with the BYOAI, it's like build your own AI. It's not BYOB, but build your own AI. That we give that capability to the manufacturer. And so if they see something that they want to understand and capture, and we give them the tools so that they can do it themselves. So it's like instead of give them a fish, that we teach them how to fish. And so that would make them, I would say they're actually a lot, they're feeling the empowerment, and they like the technology a lot more.
Yeah. See, I find that because I remember when your solution was first introduced, that's one of the questions I had. After you figure out a bottleneck, what do you do with the camera? And the answer is the people in the factory can identify another bottleneck and simply move the cameras and apply the same process there. And they don't need somebody from PowerArena coming in to do it, right? They can do it themselves.
Yeah, exactly.
Yeah, which is, I would imagine, the flexibility and of that, and also probably a cost savings to the client, right? Once you, like you say, teach them to fish,
Yes.
great benefit and desirability in that.
Yeah, and hopefully our dream is that our clients will apply our technology in a situation that we haven't think of before, and now
Mm-hmm.
they're using it to do something new.
Yeah. Now, if a client didn't have the knowledge-based sophistication yet to do a proper analysis, then PowerArena, you can help them with that?
Yeah, at the beginning, we'll work hand in hand with them. For the first 3 months, like kind of like for the first few weeks, we teach them how to use, build your own AI and train the AI to actually recognize. We usually have a line for the first launch, right?
Yeah.
So how do we work together to use PowerArena to capture the motion of the first line, and making sure that they're able to use the technology as well.
Mm-hmm.
And then data start to come out, and then our data scientists will be working with the industrial engineers to understand the data and suggest improvement. Honestly, I think the most difficult part is finding out the problem. The solution is usually quite obvious. And so, for example, one of the lines that we're working with is it's about 25 people long, and there's obviously there's a bottleneck in one of the workstation, and they are doing testing, and the testing machine is slow. So you put the items there, the operator is basically waiting for the machines to get them. And people know about that, but they don't know how to quantify it. And so they're asking for an upgrade of the machines, but then if you cannot quantify the impact, right, you cannot get the approval of it. But now we have all the data, we can measure it very accurately. And so they get the approval. And so they upgrade their testing machine. And now they remove the bottleneck. And then now the bottleneck shift to another place, which the usage of the tools. And they use some minor simple tools to help them to do some of the task. And those tools sometimes they will break down. And then if they break down, then they need additional people to help to finish the task. And that's slow, everyone's done. And then they do a better maintenance of those tools. And so the result is they improve the UPH, the unit per hour, by more than 5% in 4 weeks. So which is quite encouraging. Yeah, we have many similar cases like that. This is done by Wistron, one of the top 10 EMS. So they have a line of 17 people, but after using PowerArena, they can reduce it to 16 people, which is again more than a 5% increase in saving.
Yeah. You're a great interview because all my questions you answer in advance. So this is perfect because I was going to ask you about the results that you're achieving, and you just flawlessly kind of rolled right into that, which is good. So tell me that as you move forward, as you're having these experiences and you're working with like the Western, and I saw some of your client list, and it's a very impressive list of top name companies in the industry. And with the initial applications that you're doing, are you seeing it expand into other areas, or are you starting to identify other areas within that manufacturing environment where maybe it can be applied? And I'm just thinking, instead of on the SMT line, is it in the material side where they're prepping and putting kits together and what have you? How do you see that?
Yeah, so one way that we are moving forward is other than EMS, we are also working with other industry now, but EMS is still our key focus. And another thing is we're looking at things that is really difficult to measure in the EMS industry. So we are talking about those lines that, they just work on 10 items, and then they switch to another 10 items, and then they switch to another batch of 5 items. Like how do you understand the productivity and the performance of those operations, right? I think, honestly, I think there's no study, no official study on those scenario before, because it's changing so fast, and it is kind of also quite chaotic. And so we are trying to move into, so we started with area that, all the IE say, oh, this is what I have been doing. And now instead of me doing it, can the AI doing it? And so it's more like really helping the industrial engineers to do their job. And now we are moving into an area that, honestly, is too difficult to the IE anyway. So they're not doing it, but maybe we can start doing it and really trying to understand how to improve those kind of operation. So it's more experimental, I would say.
I see. And I would imagine that you make the job of an IE, much more effective, because how much time do they really have to sit around all day and stare at a bottleneck, right? They have other things going on, and if you can capture that and they can then analyze and focus on it, that has to be of great benefit.
Yeah, and we are seeing we are started to see other benefit. Like we have clients that they started in China, they have a very good team, and now because of all kinds of reasons that they're moving some of their work outside China, and so in Vietnam or in different parts of Asia or in Mexico, but then now it is kind of like very difficult to replicate the performance in China in the other plant, and how do they kind of like transfer the knowledge and the methodology. And so so we are saying that maybe we can use PowerArena to do that as well, so that if they use it in China, then we have all the video recorded, so it could be kind of like it could be open up for training. But also when we apply them to Vietnam, and now they have our clients have a lot of difficulties, getting into this country. When you go in, you're locked in a hotel like for 2 or 3 weeks, and so it's very difficult to move around. So is there like a way that you can understand the manufacturing situations, and so help them to debug or improve the situation remotely? That's a very interesting way. Yeah, because in the old days, something goes wrong in Vietnam, let me just fly over there and fix it. Yeah, you can't do that anymore. So
that's interesting. Yeah, I could see. And that's why I was intrigued by when I first heard about what you're doing, that you can just start thinking about the different applications of this. And that's an interesting one. That's, you're right, people jump on planes. I'm curious to see, even when things start settling down after with the COVID and everything, if how many people will really be, how many OEMs will be sending, people for a week over to China to the factories anymore, right? That's, I think they're learning that it's not as necessary as they thought it was.
Yeah, and people who really understand industrial engineering, the methodology and the way to improve it, is actually not that many. I mean, even inside big company, a lot of the industrial engineers, they have to do a lot. They have to keep the wheel going, right? They have to do. They're already overloaded with a lot of work. Like there's the MPI process and all the other stuff, and they don't have much. I would say they don't have a lot of luxury, to step back and think about, hey, how can I systematically understand and improve the line? And for some of the factory that we have seen, this is actually done by a group of just a few people, like 5, 6 people. Even for a global factory, that these 5, 6 people have the luxury to step back and trying to systematically understand the problem and suggest improvement. And they used to be flying away, very busy, but now how maybe there could be another way that they can help.
No, absolutely, and I can see where what you've created there and are working is a great tool and of great benefit to them. So that's good. I am aware of the time and know that we should probably bring this to a close, but I just want to check before I do a formal ending here, if there's anything else about your product, about your company, about what's going on that I failed to ask you so far that you would like to share.
Well, I know you got your PhD in psychology. One thing that we really want to do is we don't want it to be kind of like a big brother tools monitoring people. And that's not how, if you look at Toyota and the lean manufacturing technologies, that's not how they think about the workers, right? They actually teach their workers about IE, so that, they can understand the process and kind of like improve the process themselves instead of from top down.
Yes.
And so I'm hoping that in one day, maybe we can combine with how we encourage the workers to think differently, that they actually really want to understand the data. And it's kind of like when I do my, when I wear my Apple Watch and I do my jogging, and I'm crazy about my own performance, right? Like how fast I run, my heartbeat and things like that, so that I can be so that I can get improved.
Yeah.
So I hope that like moving forward, there could be a way that it's not just the IE using the data, but the people on the line, that, oh, how is the line, or how is my team performing, right? And how can we use the data to make the team better? So hopefully we can do something like that in the future.
No, and I appreciate that. And you added that early on, that the important thing too is there's no facial recognition within what you're doing, which would cause concern, obviously, for people and in factories. But the point being that the focus isn't on an individual person. It's on the behavior and the productivity. And I think you're right. I think most people want to do a good job, in whatever they do. And, if they're not, they need some training, some encouragement, whatever it is. Maybe it's a break in the middle of the afternoon, right? Whatever that might be, I think you're right. I think people want to do a good job and have that good sense of pride in what they're doing. So that's excellent. No, I appreciate those comments, Ken. Thank you, sir. Well, listen, I certainly enjoyed this, and I hope maybe later this year, as things continue to develop for you, that we can get further updates from you. Because I love your solution, and as you indicated, my background's psychology, so I always look at the human element in all of these things, and you have something that speaks directly to that. So, so thank you. To my audience, I would say, if you're watching this, if what Ken is doing is of interest, look him up. You can find him on LinkedIn. He has a good profile there, and PowerArena is the website. And if you can't find him anywhere, get a hold of me and I'll get you in touch with him. So, so Ken, thank you again for your time, sharing with the audience. I wish you continued success.
Thank you. Thank you very much.